Hello everyone. Today we will learn about the topic name is fiber optic communication. The course outcome: understand and analyze the constructional parameters of optical fibers and be able to design the optical system. Right. So what is the fiber optics? So fiber optics is transmitting communication signals over hair thin stands for glass or fiber. And fiber optic communication. So in this method, I'm already said that through transmitting information from one place to another by sending light through an optical fiber. The light forms an electromagnetic carrier waves that is modulated carry informations. And then why fiber? So fiber is already we know well the least expensive, most reliable method for high speed and long distance communications. And optical fiber. So optical fiber, light is kept in a core of the optical fiber by total internal reflection. So what does mean by total internal reflection? So total internal reflection is the light must be traveling from a more denser medium into a lesser denser medium like glass to air, right? So this is the diagram of total internal reflection. So the angle of incident must be greater than the critical angle. So this is called total internal reflection. And then total internal reflection, one more diagram is there, and how it does work for total internal reflection. So light travels from two categories, only one reflection and refracted rays. First one, here we have to find the denser medium, so that is called N1, that is core, and N2 is a gladding. So light travels from the surface. Light rays strikes a refractive surface. The angle at which it hits the surface, right? So the angle of incident is equal to angle of reflection. And another one is refraction. So refraction is a bending of light as passes from one medium to another medium with a different optical density, right? So here the angle, that is theta 1, it is reflected rays, and theta 2, it is called as refractive rays. Next, the sine theta. So acceptance angles, total internal reflection is greater than the sine theta. So sine theta is equal to sine root of n1 square minus n2 square. So n1 it is represented by the core, that is refractive index of glass fiber, and n2 it is represented by the refractive index of quartz fiber, that is cladding, right? So now, so this one is a core and this layer is gladding. So core is N1 and this one is N2. So another one is fiber optic internal reflections. So light travels from the core, that is incident light reflect from the core, it is called as reflected rays, and light travels from another medium, that is called as refracted rays. So that is, next one is n is equal to root of n1 square minus n2 square. So this is called numerical aperture. So numerical aperture, that is the sign of largest angle an incident ray can have for total internal reflection in the cone. So that is called as numerical aperture. So numerical aperture n is equal to root n1 square minus n2 square. n1 it is core, n2 it is gladding. So next we are discuss about the structures of optical fiber. So this is the structure of fiber. So this one is core and this layer is coating. Third one is this one is core and second layer is cladding, third one is coating. So core, what is core? So core is a thin glass center of fiber where light travels, so that is called core. And cladding, outer optical material surrounding, so this is one cladding. And third one is plastic coating, so this layer is made by the plastics, okay, so that is called as coating. And the core and the lower refractive index of cladding so are typically made by high quality of silica glasses. Through they can both be made by the plastic as well as. So that is these are the structures of optical fiber. And next, classifications of optical fiber. So classification of optical fiber, there are three kinds of opticals there. So first one, material, second one is number of modes, and third one is refractive index. So material, so what is material? So materials, here we have to using two different kinds of materials. One is glass or fiber, right? So glass fibers, so materials, glass fibers are generally fabricated by fusing mixtures of metal oxides and silica glasses. So silica has a refractive indexes around 850 nanometers, and to produce two similar materials having slightly different indicates of refractions for a core and cladding, either fluorine or various oxides such as added to silica. And first one is I'm saying materials, glass fiber, another one is plastic fiber. Already we know that plastic fibers are typically made of plastics and are of low cost. So it's high refractive index difference between the core and cladding material. So plastic fibers yield high numerical aperture and large angle acceptance. So this is material. So material, here we have using two materials. First one is glass fiber, second one is plastic fiber. And second one is number of modes. So number of modes. Here two main categories of optical fiber using in fiber optic communications are multi-mode optical fiber, and another one is single mode optical fiber. Okay, number of modes, there are two kinds of modes there. First one is single mode optical fiber, another multi-mode optical fiber, right? And third one is refractive index. So refractive index, the same. Once again, right? Refractive index, there are two kinds there: step index fiber and graded index fiber. Right? So single mode fiber. So this is called core, and second layer is cladding, that is N2. And it is transmit one signal per fiber. Okay, they have small core and transmit infrared light from laser. So this is only one propagation. So this is only one propagation, only one mode there. So single mode fibers, smaller core because greater than 10 micrometers there. So this is more expansive components and interconnections methods, but allow much longer and higher performance lights, right? So light travels from the modes, right? So this is only one mode. And second one is multi-mode fibers, right? So this is core, and second one is cladding. And here we have using the many modes are there. So these are the many modes. So many pulses of light generated by LED travels at different angles. Okay, different angles. It is used to transmit many signals per fiber. So they have large cores. Core is very large and they transmit infrared light from LEDs. So multi-mode fiber has a large core near greater than or equal to 50 micrometers was there. So this is light passing through the mode. Next, refractive index fiber. So refractive index fiber, there are two kinds of refractive index fiber. First one is step index fiber, second one is graded index fiber. And step index fiber, there are two modes there. First one single mode step index fiber and multi-mode step index fiber. So graded index fiber, only one available there, multi-mode only available in graded index fiber. So this is the difference between step index fiber and graded index fiber diagram. So first one is step index fiber, that is only one. I am already saying step index fiber, that is a single mode fiber. So single mode fiber, step index fiber has a central core with a uniform refractive index. So an outside gladding that also has a uniform refractive index around the core, right? So second one is graded index fiber. Graded index fiber, refractive core decrease continuously between the axis and gladding. So this case light rays to bend smoothly and they approach gladding rather than the refractive core and gladding boundary. And optical fiber communication. So it is based on three types: source, transmission medium and detectors. So first one source, second one transmitter, and third one optical fiber and receivers. Finally you can get the user, right? So first source it light emitting diodes, laser beam. So here they modulate electrical signals into optical signals, mostly modulated at 850 nanometers to 1300 nanometers is available there. So lasers is give high intensity, high frequency light. And second one is transmitter, already we know well, transmitter. So optical fiber replacing copper, light is used as carrier informations, much higher data, gather the data. And optical fiber, this is use of the one medium of fiber cables. And then one is receivers. Here we have to receive the signals. A detector is a device current that extract information from modulated radio frequency, current or voltage. So finally you can get the signals. And next, advantages of optical fiber. So can carry much more information. Second one is much higher data rates, much longer distance from coaxial cables, immunity to electromagnetic noise, light in weight and unaffected by atmospheric agents. It has high bandwidth and low loss. There is no need to ground and hence no voltage problems. And disadvantages of optical fiber, joining two cable fibers is difficult. And second one is the individuals working with optical fiber need to skillful. Identical installations of optical fibers is expansive. For analyzing the transmission of light in optical cables, specific instruments are required. And advantages of optical fiber. And advantages of optical fiber, there are many advantages optical fiber. First one is telephone. So telephone calls are made between different two locations that are near or far away from each other. Implementations of such communications between two different places is a difficult task. So therefore optical fiber are used that make these connections and communications between two far places easy and clear. And second one is medical applications. Medical applications, the structures of optical fibers is very flexible and small size. So the most of we have to using in medical applications, it is view the internal body parts. During the surgery of internal body parts, there is a need to transmit light, therefore optical fiber is required. So medical applications we have to use this FOC. And third one is CCTV cameras. CCTV cameras, installations of CCTV cameras requires a high initial investment. To make use of them, need to work properly for a long period of time. And computer networking, so it is very already we know familiar. Fiber optic cables can connect the device together that belongs to same network or another network. In this connected networks, optics cables can transmit the data fastly and efficiently as compared to other copper wires. And internet, so internet FOC are used in internet as they can transmit large amount of data over long distance. So it provides with the advantages such as high transmission flexibility, low weight, and etc. So internet access is available in this topic. And defense and space related applications, it is the most basic necessity in defense and space related applications is security. So FOC those provides with more security of data. In space applications, there are various tasks such as communications between satellite, high data transmissions, and etc. This task can be performed with a greater efficiency by fiber optic cables. So this is one of the very important advantages of FOC. And next, automatic industries. So today the automatic industries are expanding very rapidly for lightening the interior and exterior parts, and for providing security. Fiber optics is widely used in vehicles. So these fiber optic cables can help to transmit the light from one part to another and provides with the faster communications between them. And final advantage applications, television cable. So television cable, the use of fiber optic cables, it's widely increasing. So FOC have a high speed and high bandwidth, therefore they are used for the transmission of high definition televisions. And thank you all. Thank you so much for your patient listening. Thank you.